Welcome everyone. Today we'll do a deep dive on integrating cameras into drones. What are the challenges? What are the best practices? What are the lessons learned from the field? Drones have finally moved from hype to practical large-scale deployment and found their place in several industries and applications. Not only that many of the deployed drones carry one or several cameras, often the main value created by the drone system itself is only possible by the cameras in the first place. In the next 30 minutes, our panel discussion will explore what it means to integrate a camera system into a drone. What are the things that work? Where are the limits? And what can we expect in the future? My name is Frederik Schönebeck. I'm the Director of Product and Technology at Framos, and we have brought three people with three different perspectives on the topic. Let me welcome Markus Grieshammer, the Staff Optical Systems Engineer at Verity, a service provider for automated warehouse inventory, where drones perform monitoring and inspection tasks. We also have Chris Eheim, the CTO of Sunflower Labs, a US-based company developing fully autonomous drone-in-a-box security systems for large-scale property protection. And finally, Andre Brela, product manager at Framos, a provider of highly configurable made-in-Europe camera modules with a core focus on optical image quality for drone-based imaging applications. If you have any questions that you would like to ask the panelists during the discussion, please use the question mark icon to post your question, and we will get back to these during the Q&A session towards the end of the event. With this said, let's get started. Now, Chris, when we speak of camera integrations into drones, what is the role of the camera system in autonomous drones? Can you give a bit of a context from your perspective?
Yes, welcome everybody, and thank you, Frederick. Yeah, I mean, like you already said, the camera really sort of provides the main value in most drones, and I would even take this a little bit further and say that the camera is the main reason why most drones even exist, right? Most drones have been sold to take pretty vacation pictures, and nowadays also are often used for video productions as well, right? For the security use case like ours, the camera, of course, is also key. Our drone is essentially a flying security guard. It needs to see security threats, and it needs to detect anomalies. You know, none of this could be done without the camera on the drone. You know, instead of a fixed camera, you can program our system to fly to specific predefined locations, perform property patrols. On demand, you can also send our drone to look at any location on a property. The pilot can tell the drone what to look at, and the drone figures out where it needs to be. So, you know, again, like none of this makes any sense at all if there wasn't a camera on the drone, of course.
Thanks. Yeah, I understand where this is going. Markus, in Verity, do you see similar use cases? So what are the applications, and how do you add value to your customers with the camera system in your drone?
Yeah, thank you, Chris. Thank you, Frederick. Hello and welcome. Yeah, so let's give a little bit of an insight what Verity does. Global enterprises lose millions each year because of errors in warehouses. Verity provides automated warehouse inventory as a service. Fully autonomous drones deliver real-time warehouse visibility. The clients are provided with insights that lead to optimized workflows and increased efficiencies. The drones are equipped with multiple cameras. They serve for auxiliary tasks like navigation and collision avoidance. The main purpose, of course, is to acquire data that is processed to yield relevant user information. For example, indication of issues or confirmation of goods, or overall, the visualization of the warehouse, keyword digital twin.
Yeah, you're right, digital twin, so really mapping everything. I think a use case not only limited to drones, but of course also benefiting a lot from drones. Chris, getting back to your security use case, I think generally identifying the right requirements, the critical requirements for the camera system is always a tricky undertaking, and maybe even with drones it's even harder because often of uncontrolled environment. So can you share best practices on how you define image quality and which practical approaches you will take to define the right requirements for your system?
Yeah, defining, I guess, the camera system requirements for drones is a tricky undertaking, and it's very hard because, good image quality isn't necessarily an absolute value, right? It's like it's only meaningful to a specific task. These tasks, of course, are use case specific and can vary quite a bit from application to application. Again, a drone that is used to take pretty vacation pictures has very different task requirements than a drone that is used for property security like ours. The practical approach we take is to start by defining the specific real-world task the drone actually needs to be able to perform, right? To sort of give our customer the best value. Some examples of this might be, can I detect that there is a person at the back door, or can I read a license plate from 30 meters away at night? Right? And maybe we will talk about this a little later, but when I say can I, what I, in our case, really mean is can our algorithms, right? So for our use case, the image might look worse to a human, but our detection and classification algorithms, hit the targets in all scenarios. So that is the right camera system for us. So maybe the best practical advice that I can give is start sort of with the decisions you need to make, right? Don't start with the camera specs. It's sort of tempting to do that. Oh yeah, we want to have a 48 megapixel sensor. That is cool and nice to have, and it makes for good marketing potentially as well, but it's not necessarily the right requirement, right? So from the task, we can actually define sort of our critical requirements that we can formulate as numeric outcomes, and actually not the visual impression itself, right? So maybe you can say like, okay, we want to detect a standing person with a 95% accuracy, at a 40-meter distance, right? Or, maybe classify vehicles and humans within, 2% false rate at night, yeah. Right? From this, like we can say, okay, fine. We need a target size in the real world, right? Okay, let's say a torso of a person, 0.5 meter, a working distance, 40 meters, and a required reliability like 95%. And these then actually are the numbers that drive everything else, right? We can convert that now into the real world into pixel requirements. We define a ground sampling distance, 0.5 meter torso. Let's say we need 20 pixels to identify the person or detect the person, right? That's 2.5 centimeters, whatever, per pixel, right? So, and then from that the 40-meter distance that directly defines the requirement for the resolution and the focal length of our lens, right? So, of course, there's other things. This oversimplified. There's other factors like the modulation transfer function and spatial frequency response and so on that also affect this. But it's a simplified example, but from sort of these specific tasks, right? And then we can lead into the high level requirements we can define as sort of numeric outcomes, really, like we can derive our low level camera system requirements and ultimately define what we mean by, good image quality, right?
Something that works, that solves your application. Marcus, are you taking similar approaches in your different setting where you're mostly operating in indoor warehouses?
Yeah, I mean, I can agree a lot with what just Chris said. Maybe I have a few additional arguments that complement here. I would say what is distinct with drones that boundary conditions can vary significantly for the camera systems. So a more versatile and future-proof hardware setup is probably a good choice. You want a fast time to market, meet the customer needs, and a product with reasonable cost and complexity. Ask what is the hardware requirement and what can be solved with software and image processing to meet the needs. The relevant image quality factors depend on the application, right? So this is also what Chris said already. I give you some examples. For image appearance in a user dashboard, correct color, low noise, etc. is needed. For sharpness, specify the spatial frequency response, SFR. And I think this is really a crucial one that engineers know how to exactly do this, right? For center, middle, and corners, for example, contrast, larger 0.5 at 0.8 field at 109 per millimeter on raw image and slanted edge method, right? So this is a combination of settings you need to specify. This means understanding the needs is important to identify the relevant image quality factors, and then you can refer to standards. Beyond that, I think two types of specifications are needed. On the one hand, image quality needs to meet the product requirements for the application and is tested with a validation test. Does it make the user happy? Yes, no. On the other hand, image quality needs to meet the design specifications to be agreed with the supplier and to be tested in a verification test. And as a practical approach, I recommend design and perform tests relevant to your application. Understand the impact of various influence factors. Assess acceptance limits for pass-fail. For example, low light, what gain and noise is acceptable? What motion blur is acceptable? Identify maximum exposure time and get effective sharpness. Yeah, so I think these are the main thoughts I have to this question.
Good. Yeah, and as you say, it sort of goes in the exact same direction as what Chris mentioned. I mean, listening to what you both of you are saying, I hear you need to test with your specific task in mind that your drone needs to solve. Andre, from the other side, from a camera module maker perspective, what experience can you provide, and what would you recommend people should do?
Yeah, sure. Yeah, hello and welcome everybody as well. This is the last one starting here. So basically, yeah, all that Chris and Marcus said in the end align pretty much with what we see in the wider field there in the market. So the requirements are extremely different depending on the application, but also how, let's say, how customers are trying to solve the challenges inside there. So in the end, like you said, it's the domain of the customer. It's your domain. You know best your application, and we will never be able to explain you the application. But what we are trying to do is to understand the surroundings, the let's say scenarios that you're having, and get as quick as possible, let's say, a first iteration of hardware in hands of the customers to really start testing in the field things that are happening. A lot, like you said, SFR, MTFs, etc. The whole, let's say, imaging requirement. There's a lot that can be calculated. What we see, what is really the pain point in the whole process, is the stuff you didn't pre-calculate, stuff that you didn't expect there. Lighting situations, as you said, there's varying surroundings, there's varying. Light can do stuff that you don't expect in the end of the day, and everything happens very, very much in alignment with the physical complexity of the system here. So what we have is a portfolio that allows customers to really quickly get started with different pixel performances, different resolutions, rolling shutters, global shutters, etc. With, let's say, lenses, where I think we will speak a little bit later about, which is the most complex and challenging part in the whole system in the end, and getting them robust, and also the most expensive part if you want to have something perfect, but also how to integrate it in the platform, leveraging capabilities of those, and creating degrees of freedom for customers that allow them actually to do what they need in own force. So giving sources, giving pipelines, that are accessible, tunable, etc. to run through that. What we have seen, just at least to give some 80% advice in some direction, is we see right now 8K rolling shutters are the sweet spot. We are seeing oftenly, let's say, field of views that are reasonable, depending of course on distances, etc., of something like 70 to 100 degree, where we definitely say something in the higher range is right now the sweet spot oftenly. But this is a starting point, and from there it's really about iterating and figuring out how does it really operate in your surrounding. Then yeah, speed is key for all of that. So getting this on the table, getting this easily audible, getting everything, having everything transparently available that customers can just start and do their thing. And yeah, usually we are always there to also support with simulations, etc., specifically of the optical system to make good pre-choices and stuff like that. Yeah, in the end of the day, like you guys said, create good enough image quality. Nobody can afford a perfect system in the end of the day, and that makes economically no sense at all.
Talking about iterations and testing and trying to narrow down the parameter space, one needs to take decisions. And I think typically the first decision is you try to select the main components based on data sheets, based on theory. But then often there is a gap between what you expect from the paper and what you then see in reality. Markus, can you share examples where potentially you've made the wrong choice, and how this then affected your product and ultimately the services, the performance of your product?
Yeah, so you also mentioned the choices of the main components. Okay, I think we also need to consider the interplay of the components. For example, the best image sensor and the best lens only perform well as a module if the alignment is correct. Image plane tilt kills image quality. This means the assembling process matters for consistent high image performance. If the off-the-shelf lenses don't really suit for the application, for example, underperformance at finite working distance, consider custom lens design. The hurdle is not so high. And to the compute platform, it needs to be compatible with the sensors and interfaces. The data sheet, and you mentioned the data sheet, Frederick, so the data sheet typically specifies how many cameras can be handled. But depending on the image signal processing pipeline for multiple cameras, there might be some limitation when it comes to details. This can impact, for example, maximum frame rate and resolution. And if you really push it to the limits, for example, because you use multiple cameras and compute processes in parallel, heat can become an issue. Thermal management needs to be improved with potential impact on weight, architecture, and bill of materials. Beyond that, tools are very platform specific. This means when changing from brand A to B, this requires effort getting permissions, access to documents, and finally to actually implement the functionality you need. So I think that's the main things that I want to put here.
Good. Chris, how about on your side? Do you have made similar experiences?
Yeah, I mean, my experiences maybe are sort of more, less sort of compared to sort of the paper or the spec sheets, but more like maybe early startup sort of decisions or company decisions that, we've sort of gone wrong, or maybe they were necessary, but they were very limiting. I mean, maybe an example of this is one like in our early prototypes, our camera system didn't have an edge compute platform at all, basically on the drone itself, right? We decided that's going to reside in our base station because it makes the drone lighter, it makes it cheaper. Again, talking about sort of bill of materials, right? Like makes the drone itself cheaper as well. So the drone itself actually couldn't process sort of images or video on the drone itself, right? So maybe this was the correct decision at the time, again, because it made the complexity of the drone smaller, simpler, right? But it pretty quickly resulted in serious limitations, right? Like all of a sudden, like, again, we didn't have that in mind when we first started, but we wanted to do target tracking, right? But now we're in the situation where, well, we couldn't do that on the drone itself. We had to actually stream the video down to the base station over an RF link also, where we had to, you know, transmit it at sort of at low bandwidth, at low quality. Then we had to process it in the base station. We had to sort of figure out what was going on in the video and then send that information back up to the drone. So oftentimes, I guess, you know, that led to a lot of latency, and oftentimes our drone was basically just late in reacting, right? So that needs to happen on the drone, of course. Maybe another example of sort of the wrong choice was selecting components for the camera. We wanted to focus on low light performance of the image sensor, right? Again, maybe it's not wrong, it's just a necessary trade-off at the time, but because we focused on the low light performance of the sensor, we chose a large sensor with, you know, with few pixels essentially, right? We also selected a wide angle lens because in the security context, we thought like, well, you know, we want to provide context to the pilots to sort of see everything. And of course, then all of this led to like very low, essentially, you know, large ground sampling distances, which then, you know, once we were starting to do object detection, that sort of backfired, right? And we ended up with quite a bit of missed detections and a lot of false positives, right? I mean, I guess what it goes back to again is like when we first started, like we focused on sort of what looks decent, right, during day and during night flight, and we didn't sort of focus on object detection. And ultimately, again, like the definition of what good image quality is, right? I think sort of very early on, sort of we missed sort of you know, how we should have defined like good image quality for our use case, right?
That's the learning that you need to go through. I think there is no shortcut to that.
Yeah.
Good. Let's proceed with the next question. Actually, I think it's great discussion, but with a limited time budget, let's move one further. What we have seen is that the level of accessibility, configurability, and ultimately the level of control on the camera system is a must, is something that people request. Andre, can you speak a bit to that, a bit further from a camera module supplier? What our experience is there in terms of providing this level of control?
Yeah, sure. So basically, as I said initially, we understand as a supplier that that we need to give the full control to customers, provide different architectures, resolutions, etc. But also that yeah, we need to support them through the complete journey here. So in the end, we are focusing on a big portfolio that is allowing the customer to really iterate through their needs, and the big focus here is really on the lens portion. Like Marcus said before, actually when it's not only in the end of the day the component itself, it's the interplay of all the components. So yes, of course you start with a component itself, and you select it by having, let's say, basic criteria like field of views, like MPFs, etc., f-stops in mind that you want to or that you need to achieve. Also, let's say your let's say light sensitivity or low light performance, etc. But in the end of the day, there's so much complexity in the system that there needs to be a bigger degree of freedoms in terms of how the platform or how the lens, actually the lens design, supports the situations that customers will see. So how we do this is really with a portfolio, with listening to customers and being able to address these needs and iterating through effects they see in the field, especially where we see in the first iteration, of course, a lot of iterations, difficulties here with changing outdoor situations is light. Light is the most complicated thing here in the side, and especially the grade of a lens when starting with a €2 lens from an Asian supplier or something like that, even from Alibaba is what we see a lot of times. Looks awesome, has great MTF, has perfect specs on the paper, but as soon as I put it against the sunlight or have some moisture outside, some let's say environmental inputs, I lose my contrast, my complete resolution or something immediately. So there's a lot inside the system, a lot of complexity that really requires iterations. We are working on simulating a lot of this stuff to be able to prevent running and do time-consuming cycles there, but you can't completely, not today yet. So let's say big companies are working on simulating the whole world in the end of the day, and probably will get very close to that in the next years. But it's really about the portfolio, the transparency, working with customers, also working with simulations, working with data sets that are much more than what you will get when you're just ordering something on eBay or something like this. There's much more data for these lenses available that need to be considered, and yeah, also on software side, etc. Like Marcus and Chris said before.
Let's go there. Yeah.
So this by yourself. Yeah.
You have now, I think, focused on lenses, and there, as you say, there need to be options because different options perform differently based on the application. Chris, on the software side, on the driver side, can you speak to that? What kind of level of control you need as a system provider to ensure that your system works?
Yeah, I mean, I guess we want sort of the camera system to be highly accessible, right? And like ideally, sort of all configuration parameters can be set and retrieved via some sort of an API. We would like to have sort of almost near register level sort of control over the camera system, right? We actually don't like the camera to make any sort of auto decision for us in terms of exposure or gains or whatever, right? Because we feel like, right, our algorithms, again, they know better than sort of the camera what is needed at any moment in time in a given environmental condition, right? For example, like when tracking a fast object, maybe we'll optimize for, I don't know, short exposure times, small ROI, high frame rate, right? Where an auto mode in a camera wouldn't do that because it would want to optimize for the human experience rather than algorithms, right? So we really want to have ultimately like complete manual control over all of these parameters. Of course, then there's sort of the obvious things like the intrinsic parameters such as lens distortion, vignetting, shading parameters, bad pixel maps that should be stored in the camera and actually automatically corrected for in this case, right? Ideally, so we don't have to deal with this on sort of the consumer side, I guess, or of the stream, right? And then, because we are dealing with a tricky RF environment, and, Marcus can probably talk to this as well with operating in warehouses, but sort of we're operating between structure, oftentimes in, steel reinforced like concrete structures, right? And the radio performance and bandwidth can vary quite a bit. So we would need to have full control over bit rates and even frame rates, and ideally sort of like that without dropping any frames at all, right? Like it needs to happen on the fly. Maybe one other odd thing, and maybe I'm guessing Marcus deals with this too, sort of we locate objects in the 3D world based on the video, right, from a dynamic vehicle. So we need to have all of our frames in the video essentially synchronized with an inertial measurement unit, right? So we know exactly what the attitude and the location of the drone was when each frame was taken.
Good.
Now there's yeah, things like binning and whatnot that, for better low light performance, of course. And yeah, I mean, we've run into sort of problems with off-the-shelf products here, right? And again, that's why, when you're developing sort of a camera system for a drone, you really want to have control over all bits and pieces, right? Like we had an off-the-shelf camera that didn't allow us to control the bit rate in real time. So this was very tricky because now we had to sort of fix sort of the bit rate at a rate where it was okay during the,
Compromise, yeah.
really good RF performance, right? So that we had, still had good video and low RF performance, but it was just a sort of a compromise that needed to be made that led to basically the camera not really providing a nice video in either situation, right?
Okay, Marcus, let me ask you a different question. Now that we talked about requirements and potential limitations and level of control, I think generally speaking, for any camera system, but in particular for drones, one always needs to find the optimal balance between performance, energy consumption, size, and of course also cost. How do you bring this together? Where do you start? What is less important for you? Can you share insights on how you find this balance?
Yeah, okay. I mean, that's a bit a tricky one. I mean, eventually, camera systems development and integration is a multidisciplinary project. So what I can say is, yeah, all stakeholders need to be involved, including product development, purchasing, manufacturing, and external partners, etc. And then budget needs to be negotiated, be it cost, weight, or other metrics. Early to decide in the sensor technology, early to decide is the sensor technology. Yeah, so Andre already mentioned global shutter or rolling shutter, and then also of course the sensor format. Yeah, for example 1-inch order. A rolling shutter comes with artifacts in case of motion or flickering. Global shutter means large pixels, larger sensor, larger optics that have impact on weight and cost. And energy consumption, you mentioned energy consumption of a camera is rather small compared to propulsive power of the drone. However, the payload in grams matters. You can calculate a conversion factor of payload in grams and power consumption for flying. For example, 10 grams more means 1 minute less flight time, something like this.
That sounds like an interesting metric. So, Andre, any thoughts you have to add to that?
Yeah, it's nailing it somehow, I would say. So first thing we see also, that's what the guidance generally we would give at the beginning: pick the smallest pixel that still delivers the performance that you need and is available in the target volume, right? So going into smartphone market is usually not connected to much luck, as long as you're not going and yet in the 500,000 plus pieces or something like that. But everything else will just add weight, add complexity, cost. When looking in large lenses, large assemblies and stuff like that, that's like Marcus said, it immediately gets very expensive for the solution, increasing the size of the drone, etc. So like initially said, so we see the sweet spot there, something like 2 microns actually. Microns rolling shutter is right now great sensors that work, which are, as been said, a kind of Swiss Army knife for at least the starting point. Rolling shutter effects are much easier calculated out and corrected than actually motion blur, because you cannot collect enough light. And as Marcus said, you need to be able to have the right application with low enough resolution to get something like a large pixel in that. What we see, what might be from the power consumption perspective, probably the biggest impact that we can do to a system, considering we have motors with a couple of 100 watts in the end of the day consumption, is the processing platform. You can go from a kind of sub 5 watts thing or even less to something that has 20, if you want, pick a big NVIDIA device and burn almost 100 watts on it. So there's a lot of capability, potentials for that. And we see, depending on the application, that you can right now, many customers can survive without AI or something like that, like Chris said, going back and just uploading data and then doing the processing offline, or with something on the edge with 50 tops or something like that, that is actually quite reasonable, let's say, in power consumption and capabilities. But a lot makes also here the optimization in the end of the software. Drivers, leveraging hard IP on that, ISPs that are on that. Do an imaging pipeline on a CPU or on a GPU. The power draw, the resource you will just burn for that is huge. And you have dedicated engines who can do this without an effort in the end of the day. So there's a lot that can be optimized there.
Good. We are already a bit over time, so before we now pivot over to some of the questions that were raised during the discussion, let me ask one more question to each of you, and I just want sort of one short verdict from each of you, just one sentence. What is the future of drones in our society, and where will cameras in drones go? Chris, what's your personal verdict?
Well, my opinion, and I guess, you know, we are a drone company, so maybe I'm biased, but I think drones are basically going to be everywhere, right? They're going to be ubiquitous. There will become normal and widely accepted, right? It hasn't always been like this. I think when drones first came out, you know, people were a little bit afraid of them. They didn't like them. Now they're, you know, more common. People get used to them. They accept them. Maybe some people still don't like them, but I kind of compare it to cars sometimes, right? Like, you know, we had horse carriages and then all of a sudden there was this stinking, noisy thing going down the road. You know, people didn't like it. But, you know,
okay. Makes sense.
They're now common, very common.
They're
right?
here to stay, I think.
They're here to
that's
stay.
clear. Marcus, can you maybe speak to the question of what is the future of camera systems in drones? What's your opinion on that?
Absolutely. So my vision on future camera systems, I mean, the camera systems is the foundational tool with which a robot or UAV can sense the environment. In the past, a camera was to take a picture. For the future, I envision a highly integrated vision system, which is AI powered and capable to trigger real-time action based on VLA models. That's where I see the future.
Okay. I think I can relate to that. Andre, anything to add?
What shall I say, right? So I'm the imaging guy, so the drone specialist talked. So yes, we will see them everywhere. They will be let's say common for in every situations. I think what we will see is lots more processing, like Marcus said, to support large models and so on. You need processing power, more effective, and definitely more sensors everywhere around. So as more they interact with us, the more they need to perceive their environment, ensure that they can safely operate and so on. So multi-sensor systems are definitely the future there, and it's rather let's say more smaller sensors than one big sensor in the end of the day, just looking into let's say cross performance perspective there. So yes,
good.
Many sensors.
Many sensors, yeah. More cameras, more drones, more cameras.
Okay.
Yeah. There were a couple of questions raised. Actually, I think the first is for you, Andre. Question is, what are the possibilities to develop really small footprint lenses? So really more going into the cell phone domain. What are the options there more in this, let's say, this industrial context in which we are discussing? Please, just a short answer so that we can tackle more questions.
Yeah. In short, there are, let's say, unlimited possibilities as long as the budget is there. The hurdle for let's customization, the cost, also the process, let's say overheads, etc. Speaking about bare die bonding, which is usually very closely connected to that. So with the right budget, it's possible. So it's always a trade-off in terms of cost to no, in the end it's volume. It's mostly volume depending. Can you somehow share it over the volume, the cost? But they are there and they are big as soon as you're going into customization and optics.
Good. Then there's another question, and I guess this is more maybe answered by Markus and or Chris. This famous jello effect of a rolling shutter, when you move your device and only have a rolling shutter available. How do you deal with that? Is this an issue for you guys? Are there any best practices that you can share?
Mhm. Yeah, I mean, first of all, to understand the root cause, right? So, I mean, you have basically your tolerances when you fly, and then it can happen that you see this effect, right? So this is basically a shift of, or let's say you have a straight line and it becomes a wavy line, right? So, I mean, what you can do there's one camera parameter, which is basically the line time delay. When you choose a sensor that has a short one, then you can limit this, for example.
Okay. Chris, how about you? Is that jello effect something you need to deal with as well?
Yeah, we've had to contend with this as well. I mean, what Mark says is correct. Also, just sort of the isolation of the camera system in general from sort of the trying to decouple it from sort of the motion and vibration of the vehicle itself, of course, helps with that.
Okay. Good. Then there are also a couple of questions actually that point in the direction of how can we, what are our options when we have a camera module and we have a compute platform and there is not necessarily an off-the-shelf driver available that gives us all the functions that we need. I think Andre, you as a product manager may have heard this question, this challenge
we know this
before.
issue. Yeah.
What can you recommend?
What I can recommend is get as much control as possible over the drivers. So if you need, and of course we are speaking about embedded solutions, you will always need to be able to touch everything to the last bit there. And the only advice I can give, if you don't have access to driver sources, it's probably a bad choice.
Okay, so get to the source, and then once you have the source, at least you have options to do the driver porting to whatever target platform you have.
So we are supporting customers there as well, for sure, and we're supporting a wide bandwidth of platforms from NVIDIA, Qualcomm, NXP, Raspberry Pi, etc. So the base is always there. It's mostly about the porting, and new platforms are always difficult for sure, and we are always supporting them on project basis, but also we are trying to open, let's say, as much as possible the access to drivers to also do as much as possible by customers themselves, and often it's just really jumping to another device tree or something like that. So the core driver for the SoC is usually already the biggest barrier here, and there we are trying really to be wide and open in the end of the day to allow customers to have a swift start.
There's one last question. Since we discussed about rolling shutters quite a bit and this jello effect, the question is why should anybody then still use rolling shutters in the first place? Andre also mentioned that you actually see the most demand currently for 4K rolling shutters. And it seems also all of you in your applications are using rolling shutters. Why? Can you reason why you are still going for rolling shutters? Maybe quickly, each of you. Chris, can you start?
Yeah, I mean, one, it's hard to sort of find a sensor that is global shutter and sort of quick, I guess. It's, rolling shutter is also, usually the cheaper version. So there is, sort of a cost question there as well, right? And usually they have just higher sensitivity and higher resolution as well, right? So I think that those are probably the biggest factors for us.
And I think definitely underline the cost aspect, where global shutters at the same resolution are just a lot more expensive. Markus, similar reasons why you are also using rolling shutters?
I mean, maybe a bit to complement. So first of all, it's also possible when you have multiple cameras on your drone that you can find a hybrid solution in terms of that you have that you use both of the technologies, right? So some global shutters for the one type of cameras and high resolution rolling shutters for other cameras. apart from that, I think this is a bit what I want to say as a homework for our sensor manufacturers, right? So we hope very much for smaller pixels on global shutters. So I think at the moment, basically 2.2 microns is the smallest you can find. So I think was the latest from Sony. I think this is as big potential, and I think this is also where the roadmap goes. And yeah, so this will be exciting for the future.
Great. Any last words from you, Andre? And then we're gonna close this off.
Yeah, rolling shutters are superior just because they are simpler in the end of the day. So in a global shutter pixel, there's more happening, creating more noise, let's say allocating more space that can be used, should be used for collecting photons. So if the global shutter effect is the only thing or the rolling shutter effect is the only thing that's stopping you from using a rolling shutter, be it so. But in every other matter, the rolling shutter is superior.
Superior. Okay. Guys, thanks a lot. I believe this was a very fruitful discussion. I do hope that it was beneficial for the audience. With that said, let's close it off here.